Welcome to the 9th lecture of module 2 of the course called Game Theory and Economics. Before we start this lecture, let me take you through what we have discussed in the previous lecture. What we have done in the previous lecture is that we have defined what are known as weakly dominated action and strongly dominated actions, and we have discussed some properties of this weak domination and strong domination. In particular, we have said that if we have Nash equilibrium, then in the Nash equilibrium, strongly dominated actions are not played. As far as weakly dominated actions are concerned, in Nash equilibrium which are not strict Nash equilibrium, that is non-strict Nash equilibrium, it is possible that weakly dominated actions are played. We have shown an example of that. And in Nash equilibrium, which is a strict Nash equilibrium, we have shown that weakly dominated actions are not played. So, these are the properties. Today we shall start from there, and we shall be discussing some of the exercises related to weakly dominated actions. So, one exercise that we shall do today is whether it is possible to have a single Nash equilibrium in which weakly dominated actions are played. Notice we have already seen that if weakly dominated actions are ever played in Nash equilibrium, it has to be a non-strict Nash equilibrium. So, this Nash equilibrium that we are going to construct here is going to be a Nash equilibrium which is not a strict Nash equilibrium. But let us see if that can be constructed, and I have constructed the following game. There can be other cases also in which there is a single Nash equilibrium, and that single Nash equilibrium, in that single Nash equilibrium, the actions of the players are weakly dominated. So, let us suppose there are two players 1 and 2. One has 3 actions U, M, suppose B, and 2 has 3 actions L, C, R, and following are the payoffs. Now, if this is the game, then notice that the Nash equilibrium in this game is just one. There is only one Nash equilibrium. Which is at MC. This is a Nash equilibrium because given that player 2 is playing C, if player 1 plays M, he gets 1. If he deviates, he gets either 1 by playing U, or he gets B, he gets 0 by playing B. So, he cannot be doing better than what he is doing by playing M. From player 2's point of view, similarly, if he plays C, he gets 1. If he plays L, he gets again 1. If he plays R, he gets 0. So, he cannot be better off. We can check other pair of actions, and we shall see that in each of the pairs of actions, the actions are such that they do not constitute Nash equilibrium. So, this is the unique Nash equilibrium. At the same time, let us also see that what is the action M for 1. For 1, action M is such that M is weakly dominated by action U. How do I say that? Because if player 2 plays L, U is better than M. If player 2 plays C, U and M give them the same payoff, give him the same payoff. If 2 plays R, again U and M giving player 1 the same payoff. So, U is weakly dominating M. Similarly, for player 2, if I consider L and C, I shall see that L is weakly dominating C. So, C is a weakly dominated action for player 2, weakly dominated by L, which means that both M and C are weakly dominated, whereas in the only Nash equilibrium of the game, both of them are being played. So, here we have an example where players have weakly dominated actions and they are being played in the unique Nash equilibrium that the game has. Now, so that was one case of and one example of weakly dominated actions and how they can be played. One illustration or one example that we shall do today related to weakly dominated action is the case of voting. And suppose here the game is the following, that there are 2 candidates in the field, suppose A and B, and how many voters there are? Suppose there are n voters who can vote either for A or for B. N is odd, and abstention is not an option. So, everybody must vote, and it so happens that number of people who like A over B is more than the number of people who like B over A. So, A has more supporters. Now, if there is no abstention, then obviously there is a clear winner, and because number of voters is odd. So, either A is going to win or B is going to win. It may seem that A is always going to win, but that is not the case. It may happen that even the A voters are supporters of A are voting for B, and consequently B will win in that case. And so, how are we going to set this up as a game theoretic problem? First, the players, the voters are the players here, n in number, 2 actions, voting for A or voting for B. These are the only 2 actions. Preferences, how are they defined? Well, this is quite logical and intuitive. In all the profiles where A is winning, the voters are indifferent between them. If you remember, the preferences are defined over the action profiles. So, action profile here will be n element vector, each element representing the action of one player. So, it will look like the following, suppose A, B, A, like that. So, there will be n such elements. Now, from this it may happen that the number of A's is less than the number of B's. For all such profiles, the voters are indifferent, because in all those cases B is winning. So, if B is winning, it does not matter for a particular voter whether he himself is voting for B or someone else is voting for B or by how much margin B is winning. Those things are immaterial for any voter. As long as a particular candidate is winning, players are indifferent between those profiles. So, it does not matter by what method or by what margin a particular candidate is winning. And it so happens that the players who like to see A win are more than the players who like to see B win. So, that is the story, main story. So, what the result is that for a supporter of A or suppose B, voting for A weakly dominates voting for B. So, if I am a supporter of A, it is a weakly dominant action for me to vote for A than to vote for B, because there are only two actions to consider. And vice versa, if I am a voter for B, it is weakly dominating to vote for B than vote for A. And what is the reason for this? Look at this game from any individual's point of view. Suppose I is an individual, a player, a voter, is supporter of A. Now, if I supports A, then what can be the profiles of actions of other players except I? Now, if I leave I out, then it may so happen that in the rest of the players' actions there might be a tie. Now, if there is a tie, when leaving aside I's vote. This tie is crucially dependent on the fact that n is odd. So, if n is odd, then if I take one person out, now I have even number of voters. If I have even number of voters, there are two candidates, there can be a tie. Now, if there is a tie, then what is best for I? In that case, voting for A is strictly better than voting for B. Strictly preferable to voting for B. Now, if I have to prove that voting for A is weakly dominating over voting for B, then I have to show that in rest of the cases also voting for A is better than voting for B, or the person is indifferent between voting for A and voting for B. Now, how can I show that? What can be the other cases? Again, if I leave I out and if I consider the voting pattern of other voters, what can be the other cases? The other cases could be that one of the candidates A or B is winning by 2 or more votes. A or B is winning by 2 or more votes. In particular, the margin between these two candidates A and B can be either 2, it can be 4, it can be 6, like that. It can never be an odd number because we have even number of voters. Now, whatever be the case, if one of the candidates is winning by 2 or more votes, notice that vote of this player I is becoming immaterial. For example, it may happen that A is winning by 2 votes. In that case, if he votes for B, A is still winning because now only the margin between A and B is reducing by 1 vote and A is still winning. If I votes for A, then the margin rises, but A still wins. So, as far as the outcome is concerned, it is not making any difference. I's vote does not make any difference if the margin between A and B is 2 or 4 or 6, like that, and vice versa, in the sense that if B is winning by 2 or 4 or 6 votes, then I does not like that case, but he cannot change the outcome either. If he votes for A, B still wins by maybe a margin of 1 or 3 or 5, like that. So, in such cases, voting for A is as good as voting for B. So, he is indifferent between these two actions, voting for A or voting for B. And these basically 1 and 2, this case 1 and case 2 exhaust all the possibilities for I to vote. And if that is the case, then we find definitely that action A, that is voting for A, is weakly dominating for A weakly dominates voting for B. So, that is one result that we have, and this is for the supporter of A. For B supporters, voting for B will be such that it weakly dominates voting for A. So, that is that. Another sort of voting which we shall call collective decision making is something which we seek to discuss today. And here it is not that people are voting for candidates. People are deciding to, people are trying to decide on a common policy. So, this is trying to decide a common policy. And who are these people? Suppose there are n people, n is again odd, people who are deciding on a common policy. And this policy is such that it can be represented by a number. For the ease of visualization, let us suppose this number is a positive, or minimum it can be 0. For example, let us take the case of defense expenditure by a government. Now, people have their own ideas about what this value could ideally be. For example, someone who is more nationalistic, more rightist kind of person, he may like to have a higher value of this variable, that is the defense expenditure, than someone who is a more liberal, more left oriented person. So, every person in this story has an ideal value of this number which he likes to see as the common policy. Suppose there is an individual I belongs to this set of n people, and his favorite is given by xi star. So, xi star is his favorite number. He likes that the common policy evolved by this entire set of people, decided by the entire set of people, be closest to xi star, and this happens for everyone. So, every person, 1, 2, etc., n person, every one of them has an ideal or what he likes to see as the common policy. These are given by the stars. Now, obviously, these numbers can differ, and if these numbers differ, then how this community of n people get to decide what will be the common policy, because that common policy can be a single number. In that case, what it does, the mechanism that it evolves is that every one of these n people is asked to announce what is the number that he likes to see. So, every one is to announce his or her number, and let us call these numbers as x1, x2 ... xn. So, these are the announcements made by each player, and based on these announcements made by each player, the common policy is decided. How is it decided? The median of x1, x2 ... xn is the policy. All right. So, people announce their numbers, and then the median of those numbers is taken to be the policy of the group. Now, just to clarify what a median is, median is the middlemost number. Suppose I have a set of numbers, suppose 1, 5, 9, 20, 21. So, these are the 5 numbers. Then after I have got these numbers, I arrange them in an ascending order like I have done here, and then I pick up the middlemost. Here the middlemost is the third number. So, 9 is the median. So, middlemost number is how I pick the number. If there are n numbers and n is odd, then how do I decide which is the middlemost? I take n plus 1 divided by 2, because here there are 5 numbers. So, 5 plus 1 divided by 2 is 3. So, third number is 9. If there are odd numbers, if there are even numbers like 1, 5, 9, 20, then there is not a single middlemost number. There are two middlemost numbers, 5 and 9. So, in this case median is both. So, there are two medians here, both are medians. So, here the formula is what? Suppose this is n, then I take n divided by 2 or n divided by 2 plus 1. That will give me the serial number of the median of the medians. Here it is 4, 4 divided by 2 is 2, and 4 divided by 2 is 2 plus 1, that is 3. 2 and 3, third and second and third numbers are the medians. So, that is the definition, the idea of median. Now, if this is the setup that there are n people, they want to decide on a common policy, and each of them has a favorite policy, and each of them will like to have the common policy of the group to be closest to his favorite policy, then they will announce some numbers, and the median of those numbers will be taken to be the common policy. So, that is the setup. So, here basically if I have to set up in game theoretic terms, n people, actions, so anyone can announce a particular number, that number can be any number, it can be any positive or 0 non-negative number basically. It can be negative also, but I am just keeping the structure simple. And what is the preference? I prefers the action profile A to A dashed if the median policy in A is closer to xi star than the median under A dashed. So, basically preferences as always depend on the action profiles. So, if I is given two action profiles A and A dashed, then how does he compare, which one does he like better than the other? And the answer is the following, that I likes A to A dash, that is he likes A better than A dashed, if in A the median that is chosen in A is closer to xi star is his favorite number, his favorite policy, than the median policy which will be decided if A dashed is the profile. So, if A dashed is the profile, the median is going to be farther away from xi star than the median under A. In that case, I is preferring A to A dashed. So, this is the setup in game theoretic terms, and the claim is that, again it is related to the idea of weak domination, that for each player for each player I, suppose announcing xi star weakly dominates all other actions. Now, notice this is a more strong result than what we have seen before. In the previous exercise, there were two actions, and we saw that one action was weakly dominating the other. Here, one is saying that for each player, for example, player I, he has this action xi star that weakly dominates over all other possible actions that he can take. So, it is weakly better for him to take this action xi star. Xi star, mind you, is the favorite policy, actually the true policy that he likes to see than all other actions that he can possibly take. So, this essentially means, this result basically is suggesting that in such setup where people are asked to tell their preferences and we take the median of these preferences, there is an incentive for people to reveal their true types. There is an incentive for them to tell the truth. In many cases it may happen, as we shall see later on, in many other setups it may happen that people do not tell the truth, they want to influence the ultimate decision of the community, and that is why they tell something which is not their true types before, so as to make the final decision closest to their true decision. But here we see that that is not the case, that if people are asked to tell their types, there is an incentive. There can be cases where people will tell their true types. And what is the proof for this? The way we approach this problem is the following. Suppose I take I out, any player, I is any player, I am taking him out. I know that he has this favorite policy xi star, and the announcement he makes is generically given by xi. Now, if I take I out and I take the announcements made by other players and I arrange them in an ascending order. So, this is how they are arranged, x1, x2 dot 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 xn. So, there are n minus 1 elements here in this entire series. Now, in this vector or in this series of elements x1, x2, xn, etc., there are two middlemost elements, because here since there are n minus 1 elements here and n is odd, so that means n minus 1 is even. So, there are two middlemost elements here, and what will be their serial number? That I can find out by dividing n minus 1 by 2, because let me take an example. Suppose I have 5 elements, 1, 2, 3, 4, 5. Now, if I take 1 out, then the middlemost will be 2 and 3. Now, how do I find out 2 and 3 from by some general formula from the number 5? What I do is I take 5 minus 1 divided by 2 and 5 plus 1 divided by 2. So, I get 2 and 3, so these numbers. So, that is the same case we are doing here. Since to begin with there are n players, I am taking 1 out. So, there are n minus 1 players. The middlemost will be the serial number n minus 1 divided by 2 and n plus 1 divided by 2. And suppose the announcement made by these two players are x under bar and x over bar. And so, these people are somewhere here. Now, what I am going to do now is that I am going to consider all possible cases of location of xi star, because I has a favorite policy which is xi star, but xi star can be any value. It can be less than x1, it can be more than xn, and it can lie anywhere in between. That is one thing. And secondly, I am going to consider first case 1 is that suppose xi star is less than xi. So, which means that he is considering, player I is considering that he is going to make an announcement which is xi, which is strictly greater than xi star. Then I am going to show that this kind of consideration, whether I shall make an announcement greater than xi star, which is my favorite policy, is going to be weakly dominated by xi star. Basically, it means that if I consider making an announcement which is more than my favorite policy, that announcement is either going to give me less payoff than announcing my true favorite policy, or that announcement is going to give me the same payoff that I will get if I announce my favorite policy. And this is case 1 just, and there will be a case 2 where xi star is greater than xi. If I can prove that in both these cases xi star weakly dominates xi, then I am done. Then I am done in the sense that, which means that no matter what other announcement I take, announcing my true type, that is xi star, is the weakly dominant action. It weakly dominates over other actions. Now, so let us first take case 1. Now, remember there are all these x1, x2, etc., etc. Somewhere here there is x under bar, there is some x over bar, and here there is suppose xn. They are in ascending order. So, here is x under bar, here is x over bar. First take the case that xi star, which I know is less than xi, is less than x under bar. So, they are somewhere here to the left of x under bar. Let us consider the case of equal to also, it does not matter. Now, in this case, what are the payoffs of player 1 if he announces xi star and if he announces xi? If he announces xi star, which is suppose here, and the alternative is he is announcing something here. In either of the cases, x under bar, x over bar were the middlemost before he made his announcement. Now, when he is making his announcements are to the left of x under bar, which means that this becomes the median. X under bar becomes the median. And it does not matter really whether he announces xi star or xi, because in both the cases x under bar remains the middlemost. And so, in both these cases that in this case where xi star is strictly less than xi, which is less than equal to x under bar, I is indifferent between this action and xi. So, this is what I get from here. This is just A. What is B? Well, it can very well happen that xi star is, I know, less than xi, but this xi is somewhere here. So, that is xi is greater than x under bar and is less than x over bar. Now, what happens? If I makes the announcement xi star, so he is making some announcement here to the left of x under bar, then x under bar becomes the median of the entire population. If I makes the announcement xi here, somewhere here, then xi itself becomes the median of the entire population. And which is better, having a median x under bar is better, or having a median at xi which is greater than x under bar is better? If you remember, the preference was such that any player likes that action profile where the median is closer to his favorite policy. So, that means that in the action profile where x under bar is being chosen as the median, that is preferable to him, which means that in this case where xi is greater than x under bar and less than x over bar, for player I, announcing xi star is preferable because that is giving him x under bar as the policy than announcing xi. So, here I have a case where announcing your true type is strictly better. Let us take case C. Case C is the case where suppose xi star is here, suppose xi the announcement that he is planning to make can be greater than x over bar also, it is a very high value, or it can be equal to x over bar, does not matter. In that case, which is the better action, announcing xi star or announcing xi? Here also we shall see that announcing xi star is strictly preferable than announcing xi. Why? Because if he announces xi star like before, x under bar becomes the median, and if he announces xi which is either x equal to x over bar or greater than x over bar, then the median becomes x over bar. So, he is to choose whether it is better to have x over bar as the policy, final policy of the community, or x under bar as the final policy of the community. And since the difference between xi star and x under bar is less than the difference between xi star and x over bar, it is better for him to announce xi star. So, here xi star is preferable to announcing xi which is greater than x over bar. Now, in all these three cases, what we have done is that we have considered that xi star, the value of xi star is such that it is less than x under bar. But that is not the only possible case to have. It may have happen that I can take other cases of xi star, for example, x under bar this is another case D. In this case, notice if player I announces xi star, then that itself becomes the median, because then this is the middlemost. On the other hand, if he announces xi, again xi will fall between x under bar and x over bar. So, that itself becomes the median. And if the choice is between xi star and xi, obviously xi star is better, because the final policy is just your own favorite policy, that is the best that you can do. So, here xi star is preferable to xi. So, here I am taking the other case where xi can be greater than x over bar also. Here also it is similar. If player I announces xi star itself becomes the policy of the group, whereas if player I announces xi, x over bar becomes the middlemost, and that becomes the policy of the group. So, obviously player I will like to have xi star as the policy of the group, and so xi star in this case is preferable to xi. We are more or less at the end of this discussion. The last case I need to consider is this one. Both of them are greater than x over bar. In this case, it does not really matter. Whatever I announces, whether it is xi star or xi, x over bar becomes the median, which means that I is indifferent. So, I have considered all the cases where xi is greater than xi star, that is player I is considering some announcement which is strictly greater than what his true type is, and I see that xi star is weakly dominating over xi. He can do either worse by announcing xi, or he can do as much as good as he is doing after xi star. So, from this xi star is weakly dominating, xi, and similarly the case of xi being less than xi star, this is case 2, will be similar. There also I shall get the same thing, that xi star weakly dominates xi. So, from this both of them combining together, we shall reach the conclusion that announcing one's true type is weakly dominating over announcing some other policy for each of the players. So, that is more or less the end of the lecture. What we have done in this class, in this lecture, is that we have analyzed some of the exercises which use the case of weak domination. We have taken the case of voting and taken the case of collective decision making. That is the end of the lecture. Thank you. Define strictly dominated actions with examples. Strictly dominated action
for player I, AI dash is strictly dominated by another action AI double dash if the following condition has to be satisfied. So, this is the definition of strictly dominated action symbolically. What basically is being said is that AI dashed is worse than AI double dashed for player I, no matter what actions the other players are taking. The other players could be taking any random actions, does not matter. For every possible vector of actions of other players, AI dashed gives this particular individual lower payoff compared to AI double dashed. Examples, we can think of the first game that we discussed, which is the prisoner's dilemma game. This is the prisoner's dilemma game. These are the payoffs. Now, here there is one strictly dominated action, and this strictly dominated action is NC. And which action is strictly dominating this action? It is C. You can see this very clearly. If player 2 plays C, then for player 1 playing C is better, because C is getting him 1, NC is getting him 0. If player 2 plays NC, then again for player 1 playing C is better than player 2 playing NC. So, that is why NC is worse no matter what player 2 plays. Define weakly dominated actions with examples. So, weakly dominated actions. So, I am not writing it in detail as I did in the last time. Is weakly dominated by AI double dashed if this is for all A naught I belonging to A naught I, and this is for some A naught I belonging to A naught I. So, for at least for some vector of actions by other players, playing A double dashed I is strictly better, and for all other vectors it could be at least as good as playing A I dashed. An example: here for player 1, A2 weakly dominates A1, right. 2 is greater than 1, 3 is equal to 3. Okay. Last question: in the collective decision making game, find two Nash equilibria such that in one the outcome is the median favorite policy, in the other it is not. So, collective decision making model, if you remember, we have to find out one in which median is the Nash equilibrium. Let us suppose everyone announces the median favorite position. Okay. In this case, the Nash equilibrium is this is a Nash equilibrium, because no one can deviate and change the outcome, because the choice then becomes M. So, this is a Nash equilibrium, and that is what we had to provide. Another example when it is not. Suppose everyone announces x1 star, which is the favorite policy of the first player. In this case, again, this is a Nash equilibrium, because I cannot change my action and change the outcome. But here, what is the outcome? Outcome is x1 star, and which is not equal to M. So, this is an example. That's it.